Example 2, use half-angle identities to find exact value for the sine of 22.5 degrees. Now, this is a hint that 22.5 is 1/2 of some angles. So if we double 22.5 degrees, we get 45 degrees, or pi over 4. So the sine of 22.5 degrees is the sine of 45 divided by 2. So if we let alpha equal 45 degrees, then alpha divided by 2 is 45 halves degrees, or 22.5 degrees. Using the identity above, the sine of alpha, 45 divided by 2 degrees, is positive since 22.5 degrees is in quadrant 1. Principal square root of 1 minus the cosine of alpha, which is 45 degrees, divided by 2. So the sine of 22.5 degrees is the square root of 1 subtract square root of 2 divided by 2. Divided by 2, we can multiply by 1/2. So that is equal to the principal square root. And if we distribute the 1/2, we get 1/2 minus the square root of 2 over 4. Common denominator is 4, so we have the square root of 2/4 minus square root of 2 over 4. The square root of 4 is 2 in the denominator, so we have the square root of 2 subtract the square root of 2, all divided by 2. Since 22.5 degrees has a terminal side in the first quadrant, where the sine function is positive, use the principal square root for the final answer. Example 3, use the half-angle formula to find the exact value of the cosine of 15/12 pi. If we're going to use the half-angle formula, then 5/12 pi doubled will give us 10/12 pi, which is 5 pi over 6, which is on the unit circle. So the cosine of 5 pi over 12 is the cosine of 10/12 pi divided by 2. So we're going to let alpha be 10/12 pi. Thus we have the cosine of the half angle alpha divided by 2. And again, 10/12 is 5/6 pi. So using the identity for the cosine of a half angle, this is the principal square root of 1 plus the cosine of alpha, which is 5/6 pi, all divided by 2. So we're going to need to bring that radical, that square root, to cover the denominator and simplify. So this is the principal square root. 1 plus the cosine of 5 pi over 6 in quadrant 2 is negative square root of 3 over 2. Dividing by 2 will multiply by 1/2. So this is equal to the square root of, distribute the 1/2, 1/2 minus square root of 3 over 4. Common denominator of 4, 1/2 is 2/4. So 2 minus the square root of 3, all divided by 4. The square root of 4 is 2. So the numerator is square root of 2 minus square root of 3, all divided by 2. If you want to try this on a calculator, enclose the numerator in grouping symbols and get approximately 0.258819. Since 5/12 pi has a terminal side in the first quadrant, right, because 6/12 is 1/2 for pi over 2, then 5/12 being less than 6/12 will terminate in quadrant 1, where the cosine function is positive, and thus we use the principal square root for the final answer to be positive. Example 4, use a half angle identity to find the exact value of the sine of alpha over 2. Given the tangent of alpha is negative 1/5, and alpha is greater than pi over 2 and less than pi, and thus lies in quadrant 2, second quadrant. The angle alpha over 2 is in the first quadrant for the following reason. If alpha over 2 is in the first quadrant, then the sine value will be positive, and the final answer will be the principal square root to have a positive answer. So the reasons are that we're given alpha is greater than pi over 2 and less than pi. So for alpha over 2, we have to multiply pi over 2 times 1/2, because we have to multiply alpha times 1/2 to get alpha over 2, and multiply all three parts, the left, middle, and right, by 1/2. So in the middle, we get alpha over 2 is greater than pi over 4 in quadrant 1 and less than pi over 2. And therefore, alpha over 2 lies in quadrant 1, where y and sine values are positive. To find the sine of alpha over 2 using the identity positive or principal square root of 1 minus cosine alpha over 2. We need to find the cosine of alpha to evaluate the radical. Now we're given that the tangent of alpha is the ratio of 1 to 5, and there's a negative sign involved, and we're in quadrant 2. So y and sine are positive, x and cosine are negative. So we'll put the negative sign in denominator since the tangent of an angle is the ratio of y to x. And thus we'll draw the appropriate diagram. Angle alpha terminating in quadrant 2. Y is 1 in length. X is 5 in length. So here's roughly the situation. Draw the altitude perpendicular. Y is 1 in length. X is 5 in length. And the radius is to be determined by the Pythagorean equation. We have sum of the squares of the legs is equal to the hypotenuse or the radius squared. So radius squared is 26. Radius is always positive. So the radius is the square root of 26, which cannot be simplified. So the cosine of alpha is the ratio of x to r, or adjacent over hypotenuse. Cosine is the ratio of length of the side adjacent to length of the hypotenuse. And in quadrant 2, x and cosine are negative. So x is negative 5, and the radius is square root of 26. Rationalizing the denominator, multiply by the square root of 26 in the numerator, and square root of 26 in the denominator. Square root of 26 times square root of 26 is 26. So here's the cosine of alpha. Now we need the cosine of alpha to find the sine of the half angle alpha divided by 2. So let's make some space over here. And write the identity. The sine of alpha over 2 is the principal square root of 1 minus cosine of alpha, which is negative 5 square root of 26 over 26, all divided by 2. So simplifying, this is the square root of 1 plus 5 square root 26 over 26. And that's multiplied by the reciprocal of 2, which is 1/2. If we distribute the 1/2, we get 1/2 plus 5 square root 26 over 52. All right, let's take this a little further. Common denominator is 52. So this is the square root of 26 52nds, which is 1/2, plus 5 square root 26 over 52 is the square root of 26 plus 5 square root 26 over 52. Now 52 in the denominator is 2 times 26, and 26 is 2 times 13. When you group 2 times 2, which is 4, a perfect square, that means you can simplify the square root of 52. So we have the square root of the numerator, 26 plus 5 times square root of 26. And then 52 square root. Well, the 2 will come out of the square root of 4 times 13. So this is the square root of 26 plus 5 square root 26 divided by 2 times the square root of 13. Now, to rationalize the denominator, we'll multiply by the square root of 13 divided by the square root of 13. So we have the square root of 26 plus 5 square root 26 times the square root of 13 divided by 2 square root of 13 times the square root of 13. So in the numerator, inside of the square root, we'll multiply 26 plus 5 square root 26 times 13. So I'll multiply the radicands together. And then in the denominator, 2 times 13 is 26. So we have the final answer is an integer or rational number. So we've rationalized the denominator. And so we have simplified the sign of alpha over 2 in part D. Let's write the answer here. So the final answer, we have square root of 26 plus 5 square root 26 times 13, all divided by the integer and rational number 26.